Hey there, everyone. I'm meteorologist Craig Flint. Thanks for joining me for another Weather Academy here. We're going to do this today and then one more week next week. And then we're going to take a little break and kind of regroup. So today's topic, it's important when it comes to weather forecasting, but it's also good for you to know as well. We're going to be talking about weather in time, and in particular, Universal Time Coordinates. You may have heard of that, UTC time. And we're going to start off here by kind of a wide look. So this is a Mercator projection, which basically means it's a flat map. And each one of these lines that you see, these vertical lines, are lines of longitude, okay? So there are 24 of those. We'll go ahead and bring this up full so you can kind of see what I'm talking about here. Those lines going up and down vertically across the screen, lines of longitude. Why is this important when it comes to time and weather? Well, we're going to delve into that. So you can come back to me on camera here, and we're going to talk about these lines of longitude and the time zones and why it's important. So again, these vertical lines here, lines of longitude. Flat map, Mercator projection, there are 24 lines of longitude. So if you were to take this map and wrap it around a globe, it would cover 360 degrees. Well, the Earth rotates 360 degrees in the course of one day. So we have to do some simple math here. So 360 degrees divided by 24 is 15 degrees. So that means the Earth moves 15 degrees per hour. Well, why is this important? Well, one day equals 360 degrees. We did the simple division. 360 divided by 24 gives you 15 degrees per hour. And when you look at these lines of longitude, we want to start at the center point of the Earth, center point. And that is where you find the prime meridian. And I've kind of highlighted this in red. So this is 0 degrees longitude right here, okay? That is the center point of the Earth. As you go to the west of the prime meridian, you're in the western hemisphere. East, you're in the eastern hemisphere. Well, the United States, where we live right here, is considered the western hemisphere. So, what is UTC time? Well, it was invented in Greenwich, England in the 1800s, which is right about there, right about there. We'll bring this map up full so you can see the prime meridian that I'm talking about, this highlighted box that I have here, red. In red. That's 0 degrees longitude. And as you work your way west and east, the time changes. Those are the time zones. So let's come back to me on camera and we'll talk about this and break it down. So here's the prime meridian. As you go west for our purposes towards the United States, each one of these lines represents a time zone, okay? So 0 degrees, as you move west, you subtract 1 hour. So this is 1 hour behind 0, 2, 3, 4, 5. And I'm going to stop at that time zone because that's where you and I live. So as you go west, we have to subtract 1 hour. So here's kind of a breakdown. We live here in the eastern time zone. So when you coordinate that, we are behind by 5. So you subtract 5 from 0 degrees, from the prime meridian, and that puts us in the eastern time zone. And you can see as you go west, you subtract an hour. So the central time zone, 6 hours behind Greenwich Mean Time. Mountain time zone, 7 hours. Pacific time, 8 hours. Then you get into Alaska, which has its own time zone, 9 hours, the Alaska Aleutian time zone, or excuse me, and the Hawaiian Aleutian time zone is 10 hours behind. So take a look at that map full and you can kind of break it down. Again, Eastern time zone where you and I live here in northwestern PA, you subtract 5 from UTC, or Greenwich Mean Time. So that's a look at the time zones across the United States. We're going to complicate things just a little bit for you, okay? I know this might be kind of boring, but come back to me. So this is what we are in is Eastern, well, we have to go through daylight saving time when we fall back an hour. So we're in summertime, so we are in Eastern Daylight Time. Well, when we factor in daylight saving time, everything kind of shifts. So here's what it looks like now, okay? Notice how everything kind of shifts, all right? So we're in -5 now, but when you factor in daylight saving time, everything jumps back by 1 hour, okay? So this is a map showing saving time. So now we're only 4 hours behind. We were 5 hours, but that is shifted west when we go into daylight saving, which is the 1st of March through November. So as you go west, you have to subtract, everything kind of jumps by 1 hour. So that just kind of complicates things a little bit more, right? So let's break down the time zones across the world and who observes daylight saving time. And you can see down here in the red, well, that's the United States, so we observe daylight saving time. And you can see other parts of the world. If we bring this map up full, you might be able to see it better. The legend here, the green, daylight saving time in the southern hemisphere, so South America. The dark blue, so over towards Africa, does not observe daylight saving time. And in the pink, parts of Australia, Russia, parts of Central America, parts of Northern Africa formally observed daylight saving time. All right, come back to me on camera. Now I wanted to point out one other thing, and we're going to back it up here by 1. So we showed you the time zones across the United States and how they shift when daylight saving time goes into effect. I wanted to point out one thing to you. Arizona is a state that does not observe daylight saving time. However, if you look really closely, there's one little area here in northeastern Arizona that does. That's, I believe, the Navajo Indians. So there's actually a tribe in Arizona that does observe daylight saving time. Meanwhile, the rest of the state doesn't. So there's one little spot there in northeast Arizona that does observe it. Meanwhile, the rest of the state does not. So I just thought that was kind of interesting to point out, at least in terms of the United States. Hawaii doesn't either. And then these are the time zones, or the countries and continents around the world that observe daylight saving time. Okay, another thing I wanted to talk to you about in terms of time and weather, and I'm going to tie this all into weather. I know I'm kind of throwing a lot at you here, but I wanted to talk to you about military time too, which is also important when it comes to forecasting. And it's, like I said, good little tidbit for you guys to know as well. So when we talk about military time, it is a 24-hour clock, all right? So you can see here 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but then it keeps going in military time. So we go 13, 14, 15, 16, 17, 18, so on and so forth. It doesn't stop, okay? It's a 24-hour clock. So if someone says to you, I have an appointment this afternoon at 1600 hours. What is that? 1600. Well, you just look here at the coordinates on this clock face that we've got for you here. You find 1600, and that's 4 o'clock. So this is important to us because all of our weather data that we look at to produce the forecast is either in universal time or universal coordinated time or military time. So if you are interested in forecasting, you kind of need to know how to correlate these times, all right? So military time is something that we use when it comes to weather forecasting. Let's bring this one up full just so you guys can get a good look at that one. So again, military time, 24-hour clock, all right? And you can see how it coordinates going around. So 1 o'clock a.m., 1, 2, 3, 4, so on and so forth. But then when we get to noon, again, it keeps going round and round. 13, 14, 15, so on and so forth. Now that's important to us as meteorologists because that's how our data comes into us. It all comes in either in UTC time or in military time. So you need to know when a model initializes, say at 6Z, you need to know what time that is and what it correlates to. So let's take a look at an example of this. So this is kind of an old message, and I'm not going to get too into the nitty-gritty of what you're looking at, but this is what we call model output statistics. A lot of numbers here. They all mean something to us as meteorologists, but this is a good example. UTC time important to forecasting. So basically what you're looking at is a projection from the AVN model, which stands for the aviation model. We don't really use this one too often, but it's a good example because I wanted to show you this. We have other models that we look at, GFS, NAM, and they all put out this printout of numbers that we look at. So temperature, dew point, cloud cover, wind direction, wind speed, probability of precipitation 6 hours, probability of precipitation 12 hours, chance of thunder, so on and so forth. So all of those numbers mean something to us. What I'm going to do is highlight what I want you to really focus in on. And what I've done here is put it in the red box. So let's bring this one up full. And I know these numbers are really hard to see, but that's why I put this little red box around it. What you're looking at here in that row are the hours, okay? Notice they go 06, 09, 12, 15, 18, 21, 00, 03, 06, 09, 12. Is that ringing a bell to you? Well, we just kind of talked about why time, universal time, and military time is important. So 12, let's just take 12, for example, on the hour here. 12Z is correlates to 8 o'clock for us, okay? 15Z is 11, 18Z is 2, 21Z is 5, and then 00Z is 8 p.m. So that's kind of a look into our world here on how the weather and time aspect of forecasting is important. So remember, if it's 12 noon in Greenwich, England, come back to me if you want. And what I'll do is I'll go back through the maps here. Just let me click back through real quick because I'll kind of bring this home for you. Let me go back to the Mercator map there, show you the projection. There we go. Okay, so if it's noon in Greenwich, England, okay, any idea what you might do? Well, if you said you subtract 1 hour for each time zone, you're absolutely right. So noon, subtract 1 would be 11, 2 would be 10, so on and so forth, okay? So you just subtract the hours as you move west of the prime meridian. So if it's noon at Greenwich, England, and we're in the Eastern time zone at -5, it's 7 a.m. here, okay? So that's why it's important in terms of timing when it comes to forecasting. So you got to know when the models initialize and what those universal time coordinates are. And also military time is important to us as meteorologists as well. So that's just kind of a look into our world in terms of forecasting and how everything, you have to kind of deduce everything, not only when it comes to time, but other things, other parts of the forecast like temperature and wind, which comes over in knots, temperature in Celsius. You have to convert all of those, and time is just another aspect of how we come up with the forecast. All right? So weather and time, important. I know it was kind of confusing, might have been a little boring, but it's kind of a good thing to know. Important to know your time zone and what that means when, say, someone says, like I said, 1,600 hours. You should be able to kind of compute those in your brain and say, oh, okay, 4 o'clock. So just kind of a little tidbit for you. Thought it would be kind of interesting to discuss. Maybe it was, maybe it wasn't. But it does help us tremendously when it comes to forecasting. All right, we're going to leave it there for today. Again, kind of an interesting topic. I thought I would delve into it a little bit more, the time zones of the world and how they are important to weather. I know I threw a lot at you, so if I confused any of you, I'm sorry. You can go back and rewatch it. Of course, these are on the website, yourerie.com, which is where you are right now. Under weather, you can click on Weather Academy and you can review any of the topics we've discussed. We've discussed quite a wide array of them, and we have a few more to go before we kind of go on a little hiatus as well. So that's going to do it for this edition of Weather Academy. We will see you next time. Thanks for being here. Enjoy the weekend. We'll talk to you soon.